Hello everyone. Today we are going to discuss the next mechanism called as third type, that is interchange mechanism. Before starting this mechanism, we have to first memorize last two mechanisms. Which are the last two mechanisms? First one is, that is the dissociative mechanism. And second one is what? That is the associative mechanism. Okay, now what happens in dissociative mechanism? For example, ML5, okay, here this is ML5X, this is dissociates as, this is a dissociation, that is a slow step, okay, that is RDS, redetermining step here, that is ML5 plus X. That is what happens here, that is the bond between centrometal ion and the leaving group, which is called as a X, can be broken. And here coordination number of this complex, that is octahedral, that is equal to 6, and it can be decreased by 1 unit, that is equal to 5. This is called as an intermediate one. Now in the second step, what happens here? Here ML5 again combined with the entering ligand, here entering ligand, that is such a, it is called as a nucleophile. There is formation of ML5Y. Again the coordination number is equal to 6. Now whatever may be the intermediate is formed here, it is of a square pyramid. Okay, this we have seen in the last two lectures. Now what is an associative? That is first step is what? MA5X plus entering ligand, here this is a slow step, also RDS, okay, and here association is takes place. That association here takes place in a second process, okay, that is there is formation of a 7-membered complex MA5X and Y, here 7-membered, okay, here Cn is equal to what? That is equal to a 6, here which can dissociates in faster step dissociation, that is the bond between M and X is broken, and there is at the time the bond between M and Y is formed, A5Y, that is Cn is equal to what? 6. Okay, up to this then there is graphical representation and some characteristics of this dissociative mechanism and associative mechanism we have seen. Now we have to see the interchange mechanism. Whatever may be the dissociation and association here, first point is that is in interchange mechanism, what happens here first, that is dissociation and association may takes place simultaneously. Okay, that is one can imagine that here what, that is the interchange mechanism takes place in a one elementary step. That is, this interchange mechanism takes place in a one elementary steps. What happens here? Here ML5X plus Y, here what happens here? That is here X, that is equal to MLN, okay, and here is equal to Y. The bond between this is broken now here, and there is formation of MLNY here, that is Cn is equal to 6. Here what? That is Cn is equal to 6. Okay, this is a nucleophile. Okay, and this is a Lewis base. Okay, what I am saying to you here, that is, imagine that interchange mechanism takes place in one elementary step here, that is a dissociation and association takes place as a simultaneously. If we can see the graphical representation, what happens here? See the graphical representation as like this. Here E, reaction progress. This is of a R. This is activity state, that is an interchange state here. Okay, and this is a product state. Okay, as far as when, first point, we have considered that is when the reaction turns to products, formation takes place through intermediate I that is what this, and this, if we consider this intermediate I of which two types, which are the two types having the, here the intermediate I having a long lived and intermediate I having a short lived. Okay, what I am saying to you, that is when the reactants to products, this path is takes place through the intermediate I, that is from this R to through the intermediate I, through its activation state. Here what happens, whatever may be the intermediate, it is a long lived. If the intermediate having the long lived, it can be said that here the interchange mechanism IM can be distinguished. But in other words, we can easily say that as the intermediate I is long lived, there can be interchange mechanism can be distinguished. That is, if the intermediate is a short lived, at that time there is a possibility of either the mechanism is a ID or either the mechanism is a IA. Okay, either the mechanism is a ID or either the mechanism is a IA. Okay, now here for the ID here, okay, what happens here? Now ID means what? That is the dissociation mechanism, and IA means what? The association mechanism. Okay, now in the reverse way, if we consider here, that is in the reverse way, what is going to on? That is, if the I, that is the intermediate I, is of a short lived, apparently it can be said that if it is a short lived, it may be a interchange mechanism, and if it is I is a long lived, that is there will be a chance to distinguish between it may be a ID or it may be a IA. Okay, that is, it becomes to a dissociation mechanism to this, that is a IA. Okay, that is, we can't distinguish between ID and IA here. Okay, now the third point is that, see here, when interchange mechanism is occurs, there may be a possibility of a bond breaking process. Bond breaking process is less than that of bond formation process. Bond formation process, that is of M ln X, okay, plus Y. Here there is formation of this M ln dotted from this Y, and there is formation of this what? MlNY. That is, at the same time as the interchange mechanism, what happens? That is the bond breaking process here. Here this is a bond breaking process, okay, and this is what? A bond formation process. Bond formation process here, okay. Now here the rate of bond formation is a low, that of the bond formation, bond breaking process is a slow. At that time bond breaking formation process is a fast one. That is, bond breaking is less than that of bond is formation 1. That is, in other words, if bond breaking between the reactants two with a bond breaking process here one can, if the bond breaking process between the reactants and the bond breaking process here predominantly it can say that this is a what? That is the dissociation mechanism, and in which if the bond breaking between and if the bond bond formation between MlN and Y is predominant, we can easily say that what? That is, it is a associative mechanism. It is a associative mechanism. Okay, what the points forward? What I am saying, if the bond breaking process between reactants and this is leaving group, that is a X, predominantly at that time which mechanism? That is a dissociative mechanism here. And if the bond formation between metal complex and this while, that is the entering ligand, which is a nucleophile 1, is predominant, at that time associative mechanism takes place. Now we can consider here, that is the, in short here, whatever may be the next step, that is the rate determining step here. Rate determining step. In which what? It is of 3 mechanisms. First is in SN1, second SN2, and third is about interchange mechanism. So first of all, we will see about its SN1. SN1 means what? That is, it is nothing but a dissociative mechanism. For that purpose, if we consider MlN gives rise MlN X, it gives rise to MlN plus X. This is a RDS. Okay, that is a rate determining state. That is, as coordination number is equal to 6, that is coordination number is equal to 5. This step is also called as a bond breaking process. It is also called as a dissociation. Okay, and as far as its rates is considered, that is, rate is directly proportional to concentration of MlN. Okay, therefore, if we replace this proportion sign, we can take some constant that is equal to K, that is equal to MlN here. And as the rate of a reaction depends upon only one component of its concentration, therefore this SN1 is of first order. Okay. As far as its example is considered, for example here, NaH2O, 6 2 plus may be dissociates into, that is NiH2O 5, okay, that is equal to 2 plus H2. In which, in the second step, that is what? NiH2O 5 2 plus NH3 here, okay, gives rise to formation of this NiH2O 5, okay, and here NH3, okay, 2 plus. Thus, this is the example of a dissociation, that is a SN1 reaction mechanism, okay. Now we go for the second, what is what? Association mechanism. Here first, in first step here what happens here? That is here the dissociation, rate determining step here, okay, that is a slow step, and this is a what? That is association step, that is it is a fast step. Can you understand this? Yes, okay. Now we are considering the second mechanism, that is called as a SN2 mechanism here. See here, in SN2 mechanism, in this SN2 mechanism, what happens here? What? That is here again, it is in first is a association step here, and then dissociation step. All of you students, my request is that is you have to remember what is the first step is in SM1 or dissociation, and what is the step first in SN2 reactions or in association mechanism. For example, see here M ln X plus Y, here formation of 7-membered M ln X and Y in the first step here. This is the first step, this is a slow step, that is it is a RDS, okay, and there is formation of M ln Y plus X, okay, Cn is equal to 6 here. Here also Cn is equal to what? Here 6. Now specification of this, that is the step 1. This step 1 is a step 1 is a RDS, and as the rate of a reaction, second point, it is depends upon, is directly proportional to concentration of what? M ln X into concentration of a Y, that is directly proportional to complex into a nucleophile. Therefore rate is equal to what? K into what? That is the complex into a nucleophile, okay, and as the rate of the reaction is depends upon the both the components of a concentration, therefore SN2 mechanism is of a second order, one, okay. Now the next example for this is, that is NiCN4. What this? NiCN4 2 plus give rise to what? That is NiCN3, okay, that is equal to 2 plus here plus Cn minus, but we have the isotopic 14Cn, it can be immediately reacts with this, and there is formation of NiCN3 2 plus here plus 14Cn minus, there is formation of NiCN4, that is equal to 14 2 plus, okay. This is the example of a which, that is the SN2 reactions, okay. Now we go for the second point, that is the last mechanism, that is what? Here the interchange mechanism. Here that is the rate, the second is equal to K2 into complex into a nucleophile. This is of which? That is the SN2, that is equal to a second order, second order. Now we come to the third point, that is known as a interchange mechanism. Interchange mechanism. Already we have stated that in interchange mechanism here, what happens here? That is here bond breaking and bond formation steps may take place simultaneously. That is, apparently when we can say about from reactant to its activated complex, having either a short-lived or a long-lived. Either the type of these two of a intermediate of a, this is activated complex of a, it is called as an intermediate. Okay. Either it is a short-lived or a long-lived. If it is a long-lived, it is maybe of a interchange, and if it is a short-lived, it is maybe of a ID or IA. ID means what? That is the dissociation mechanism. IA means what? That is the associative mechanism. But apparently, if we reverse this, the condition, if the conditions are gets reversed, that is the short-lived is of interchange mechanism and long-lived is of which? That is the ID or IA. Thus, we cannot distinguish whether the mechanism is a according to ID or a mechanism according to a IA. For that purpose, again, the two scientists in the interchange mechanism, see here, the scientists Eisen and Wilkinson here propose that in the formation of a complex, that is nothing but this complex, that complex is formed as a pre-equilibrium complex here, okay, and thus whatever may be the second step, this second step is a slow step, according to scientists Eisen Wilkinson. In which mechanism? That is the interchange mechanism. Okay, now according to that, we take the example general M ln x plus y here, formation of M ln xy here, and this is called as what? That is the pre-equilibrium complex. Okay, and whatever may the pre-equilibrium complex, it may be converted into a M ln y plus x, but this step is called as a slow step. According to which scientist? That is Eisen Wilkinson. That is, they proposed in that way for the formation of a complex according to the pre-equilibrium complex. Okay, thus we have here discussed about what here? That is the three mechanisms along with its revision type, and the third mechanism with a interchange mechanism. If you have any doubts, please ask me on this group. I hope that all of you, if you like the video, please share and subscribe the video. Okay, thank you.